Alright folks, today I'm going to show you a little trick that I think is very worthwhile with the VEX equipment and the batteries. This is the typical end connector that's on the batteries when you first get them, and they plug into the cortex just like this. Over time I've noticed that some of these actually get stuck, these connectors get stuck in here, and students will likely pull on the actual wires instead of the housing here. So I've come up with a fix for that that kind of modifies the connector type so that you're not constantly plugging and unplugging from the cortex. So let me show you what that is. I use a Powerpole connector that I've put on the battery, and then I also use a connector here with a Powerpole end on it so that I can connect the battery, and then this part actually stays in the cortex. So when you remove a battery, you're just unplugging this portion, so that way it keeps this from being damaged from the constant use in and out of a battery. And these are great little connectors. They kind of self-clean as they rub past each other. Again, they're called a Powerpole connector, and if you look in the description, I'll have a list of all the items that are used in this video today. But a Powerpole connector inside, or Powerpole connector inside, so inside of this plastic housing, there's a little metal spring, but then this sits on top of the spring. So it kind of sits right in there like this. And then when you plug another one into it, what you're doing is you're taking these metal contacts and you're rubbing them past each other, and that's the connection that it's making. And every time you bring them apart and together, you're actually scraping a little bit of the oxidation layer off, so it makes a great connection. Should last well beyond the life of the battery and most likely the cortex itself. So it's a great little hobbyist connector. Let me show you how to do this, how you get this set up. So the first thing that I do is I usually make this part. So I ordered a bunch of these Tamiya battery connectors, basically one of these for each cortex that I have. So just open this up, and this is ready to go. So I just need to strip a little bit of the casing off the wires at the ends, and then I can crimp on these Powerpole connectors. So let me show you how I do that. So first we strip the wire, and we want to strip enough wire so that the Powerpole connector actually is kind of covered. So that's maybe a little bit too much, you know, by about a 1/16 or an 1/8 of an inch or so. So I can always go back, and if I strip a little too much, I can clip, you know, the end off. Little twist, and again, we should cover, and that looks pretty good. And then I'm going to use a crimper to crimp that down. I'm going to go ahead and strip the other side, get that one ready as well. Again, I'll test it. Looks pretty good as well. Now here's kind of the key is I always put the red on the left side, and I want my connector with the metal tab down onto the table. So that makes the orientation of this tab, I call this the flat side because it's not offset. This flat side is going to be down as it inserts into that connector. So when I crimp it, I need to make sure that it's oriented in this fashion, and I put the end on so that that tab is facing down. Now it's not a huge deal if you mess it up, because these will actually spin a little bit, so you can rotate it into the position you want. When it comes in, when it's important is when you actually have a battery where you can't rotate the wires. You need to make sure you get that right. But it's good practice. This is a $40 crimper. It's well worth it. Again, it's a Powerpole crimper. It's self-ratcheting, and then it self-releases when it gets to the end. So you just kind of click, 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 and then when you get to the end, you just keep squeezing, and it'll auto-release. Inside, You have for 15, 30, and 45 amp Powerpole connectors. I have 30 amp ones. So this actually just, the little tab goes down, and it goes into that little channel right there, into that hole. Put that in there. And then I can put the wire in, and again, since the tab is down, I want to make sure that this one's on the left, and then I'm going to insert it just as it was on the table. Just like that. And now I'm just going to crimp. So get it started, make sure that wire is in position. Crimp all the way down. And now it's crimped in place. Again, if I were to set this on the table, if you notice that flat, so get it from this side, that flat side is down right there. I'm going to do the same thing with the black. Again, line it up so where the flat side would be down. Put the connector in the crimper, the wire in the connector, crimp, and there we have it. So there's the first part, and then we just take our connectors here and we just insert them and then just give them kind of a push into position. Now sometimes they can be stubborn and not want to go, so we can use a little screwdriver to kind of force behind it. Sometimes your wires aren't stiff enough to, to be able to push and get them to insert in. So this one's being stubborn, so just make sure it's lined up correctly again. Again, here's the bottom, so it's being aligned just like this to go over that metal piece. So a little screwdriver behind it, push on the metal part of that casing. There it goes. And then if you look, you can kind of see inside of there. See if I can autofocus to that. Kind of see inside of there the metal clip, and then if you listen and watch, that goes right over top there, and that's connected in place. That's not going to come out. Then we do the same thing with the black one. Being stubborn again. There it goes, and it actually went in and clicked, so that one's good. And then to connect them together, again, the bottom should both be toward the table, and then I'm just going to insert, there's a tab on the black one, and there's a little slot on the red one here. So I'm just slide them together. Just like that. Now you've made your extension cable. This would then be connected to your battery. So this connects right up, and then this can then go into your cortex. For the charger, I actually use the end that I cut off of the battery. So when I cut the battery to put the end on, I just leave I cut about 2 inches for this side, and I leave a little bit longer length on the other. So maybe 1.5 inches. So be quick, because again, you're going to create a little short spark when you do that. So I cut the end off, and I do the same thing. Strip, put the metal connector on there, and then insert it into the power pole, and put this, again, power pole end on this, and now this will be my adapter that goes on all of my chargers. That way, again, on the charger, the only thing I'm plugging and unplugging is a Powerpole connector. So this goes on all my chargers, and then on the end of this battery, I can now put the Powerpole connectors on that as well, just like I did on this one. This battery has a little bit shorter wires because just in general the battery had shorter wires. So I'll put Powerpole connectors on the end of that. Again, all my batteries now will have Powerpole connectors. And the beautiful thing about this is because now not only can you power your Cortex with a battery, but check this out. So here I have my, now how many of you remember the old Fisher Technic transformers? You guys remember those? I've got a bunch of these. I don't know how many I have, probably around 45 of these sitting in a cabinet. Well, I put them to use. So I took the end and I clipped the end off, and I put a Powerpole connector on the end of it. The white line is the positive and the black is the negative. And if you don't believe me, make sure you check it with a multimeter. But now what I can do is I can put the end of this on, and the rating for the cortex is up to 15 volts. So this is a 9 volt 1 amp. This will plug in great. So now I can plug this into the cortex, and I can plug this into the wall, and when I turn it on, I can actually get my cortex to be powered by a wall adapter now, instead of using batteries all the time. So for the advanced projects and things where I don't need mobility, I can save my batteries and I can have students just plug into the wall instead. So it's a great little option. The only thing that we've noticed is that, again, the power supply only supplies 1 amp, so you have to, if you have a lot of motors, then it's not going to work great. But again, it's a great little fix, especially for doing the test bed and some of the smaller advanced projects that don't require a bunch of motors drawing current. Thanks, have a great day.